Hey guys, so today we're going to talk about division, which we've kind of already looked at, so it should seem kind of intuitive to you that we've done this. So for division, which is really just fractions, they look like fractions. There are two ways of thinking about this. So I'm going to show you both ways, and depending on the situation, you might switch how you do the problem. Okay. In example 1, it says x to the 10th divided by x to the negative 5th. So one way of doing this is taking this anything with a negative exponent and moving it like we have been. So he wants to go up. And then, but x to the 10th has a positive exponent, he stays. So it's really x to the 10th, and now it's going to multiply by x to the 5th. Remember that once you move it, it becomes a positive exponent. And so we now add the exponents, and so our final answer is x to the 15th. There is another way of doing this that we're going to use when we come to other lessons in the future, and that is just to subtract exponents. Since division is the opposite of multiplication, and in multiplication we add exponents, you could think of this as subtraction. So I'm going to redo this problem a different way, and that is I'm going to take x to the 10th and x to the negative 5th, and I'm just going to keep them where they are, and I'm going to subtract. And the way I'm going to subtract is 10 minus negative 5. And 10 minus negative 5 is really 10 plus 5. So this is telling me that this is going to be a positive 15th power, which tells me it goes to the numerator, x to the 15th. So you can always do that, and we are going to use that in certain situations in the future. Right now, you kind of have the option. It's up to you. So if you look at example 2, you're going to go through the variables. You can't ever leave like an x over an x. So these two here, x's, have to get simplified. Now they're both positive exponents. If they're both positive exponents, we discussed this, that you're really just going to subtract the exponents. 6 minus 2 is x to the 4th. And whichever one is higher, like the x to the 6th is higher, that's where they end up. So you end up with x to the 4th power in the numerator. Okay? Had they been reversed, then x to the 4th would have been in the denominator. And we talked about how each x over x cancels out, and that's why that's happening. Now, if you look at the next pair, the y's, I usually do it this way. Y to the negative first wants to go down, and when he moves down, it becomes y to the first, positive first. And now it's going to multiply by y to the 4th, and I end up with y to the 5th in the denominator. Now, in the z's, I have both of them have negative exponents. So z to the negative 8th wants to go down, z to the negative 4th wants to go up. So I'm going to move him up and move him down. They become positive exponents. Now I can subtract. Again, I'm subtracting because each z over z cancels out, like I showed you the other day. So 8 minus 4 gives me z to the 4th. Whichever one's higher, this guy's higher, it ends up in that spot, z to the 4th, because there are more z's in the numerator. And that's my simplified answer. Okay, why don't you guys try example 3? Miss Espinoza will pause the video. Okay, for example 3, first you should look at these coefficients. 10 and 18 have a common factor of 2. So this is going to be negative 5 over 9. I'm going to start my fraction over here, negative 5 over 9. For the a's, this a to the negative 2nd wants to go up, becomes a to the 2nd, and I'm going to multiply times a to the 4th, and I'll get a to the 6th, because I'm adding those exponents. For the b's, I don't have any negative exponents. Nobody's going to move. I'm just going to subtract. Now I can mentally just go 12 minus 6 is 6, b to the 6th, but there are more b's down here in the denominator. So that tells me I'm going to have b to the 6th in the denominator. And then for the c's, I have this guy has a negative and this guy has a negative, so they want to flip-flop. C to the 10th goes up, c to the 2nd goes down. Now I subtract those exponents, and I have c to the 8th in the numerator, because that's the higher amount of c's. And there's my simplified answer. Now we're going to be looking at fractions that have a negative exponent on the outside. For example, a really simple one is example 4, 2/5 to the negative 3rd. I'm going to ask you guys to do this in 2 steps. So first, take the negative, and remember that a negative exponent means reciprocal. So I'm going to ask you to first just flip the fraction, put the 5 over the 2. Now, once you've taken that reciprocal, the exponent is now positive 3, because you already used that negative by flipping it. And now, just cube everything. 5 times 5 times 5 is 125. 2 times 2 times 2 is 8. Okay, now we're going to take it to a more complicated example where you have 5a squared b over 2b cubed all to the negative fourth power. So here you're going to do the same thing. You're going to first deal with the negative and the exponent. The negative and the exponent tells you to take the reciprocal. So I'm going to just use this and say, okay, I'm going to take the reciprocal. I'm going to flip the fraction. So 2b to the third goes up, 5a squared b goes down. Now this is all to the positive fourth power. So we're going to raise everything to the fourth power. So we're going to go 2 to the fourth, 2 times 2 times 2 times 2 is 16. B to the third to the fourth is power of a power, so I multiply b to the 12th over, now we're going to do 5 to the fourth power. So that's going to give you 625. And then we're going to again multiply power of a power. So a to the 8th and then b to the 4th, right? 4 times 2 and 4 times 1. Now, never leave, always look at your answer and see if there are any of the same variables. Never leave the same variable over itself. That's kind of like a new rule. All right, that has to get simplified. Subtract those exponents. 12 minus 4 is 8. This guy's higher in the numerator, so that's where they end up. So my final answer is 16 b to the 8th over 625 a to the 8th. All right, so never leave, always check back at the end to see if you have the same, like a b over a b or an a over an a. Okay, on this last example, I actually want to change it a little bit. Let's change it because it doesn't have any negative exponents. I think I intended to put negative exponents. Let's put 2x to the negative third yz over 3x to the fourth y to the negative second, all to the negative second. So I just want to show you that when you have an example like this, you're going to take this negative exponent again, you're going to start there and take its reciprocal. When you flip this fraction, all the negative exponents stay negative. So 3x to the fourth y to the negative second flips up, and 2x to the negative third y to the z flips down. You don't change any of those exponents because all you've done is just flipped it and kept everything the way it was. Now everything's going to be to the positive second power over here. So we're going to square everything. 3 squared is going to be 9. Then we're going to square x to the fourth. That's going to be x to the 8th. Then y to the negative 4th. And then I'll square 2. It's going to be 4. I'm going to square x. It's going to be x to the negative 6th. And I'm going to square y. It's going to be y squared and then z squared. Now I can simplify. So if I simplify this, remember you've got x to the 8th and x to the negative 6th here that can be simplified. This guy wants to go up. So I'm going to move him up. He's going to become x to the 6th, and he's going to multiply. I'm going to add those exponents. So I'm going to have 9x to the 14th. Now with the y's, this y to the negative, this y to the negative 4th wants to go down. So I'm going to move him down, right? It's going to be y to the 4th in the denominator. And then I'm going to add the exponents, so it'll be y to the 6th in the denominator. So I have 4y to the 6th. And then z squared doesn't have any other z's, so I'm just going to leave them in the denominator. And that's my final answer. All right, so you have several of these to do for Friday. All right, tonight you're studying for your quiz tomorrow. All right, I'll see you guys tomorrow. Thanks.